Okay, 3.4. From your note card, you're told the sine of a plus b, or whatever I had you write down, is the sine of b cosine of a, or sine of a cosine of b. Bierschbeck, what are you doing? A, b plus cosine of a sine of b, right? So if we had the sine of 7 pi over 12, we're basically doing the same thing as we did for the cosine of 7 pi over 12. What was the cosine of 7 pi over 12? Well, it's 3 pi over 12 plus 4 pi over 12, right? So it's a sine of 3 pi over 12 plus 4 pi over 12, which is really the sine of pi over 4 plus pi over 3. And it's no different than what we did with the cosines, except for the different formula. So it's a sine of a, so sine of pi over 4, cosine of pi over 3, plus cosine of pi over 4, sine of pi over 3. Okay, so then sine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2, plus cosine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. So simply square root of 2 over 4 plus square root of 6 over 4, which is square root of 2 plus square root of 6 all over 4. Does it look really any different than what you did for section 3.3? No, it does not. Till we get to tangents. Tangents are a little more complicated. Okay? So, let's say we have the tangent of 165 degrees. What two angles add up to 165 degrees? (135 and 30. Those are easy ones. So the tangent of 135 plus the tangent of 30 over 1 minus the tangent of 135, tangent of 30. And you're going, Birschbach, where did you get that? Well, you wrote that formula onto your note card. Tangents with a plus, tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. Okay? Tangent of 135. Now, from your unit circle, you know the tangent of 135 is -1. The tangent of 30, well, 30 degrees, your sine is square root of 3 over 2. Nope, your sine is 1/2. Your cosine is square root of 3 over 2. So if you multiply both top and bottom by 2 here, the tangent of 30 equals 1 over square root of 3. Can't leave the square root of 3 on the bottom. So you multiply top and bottom by square root of 3. So the tangent of 30 is square root of 3 over 3. Kind of an ugly fraction, but it's all right. Tangent of 135 we said was -1. Tangent of 30 is square root of 3 over 3. So your numerator is -1 plus square root of 3 over 3. Your denominator is 1 plus the square root of 3 over 3. What problem do we have with this answer? It involves complex fractions, right? How can I get rid of my complex fractions? Multiply by the denominator of the denominator. So we get -3 plus the square root of 3 over 3 plus the square root of 3. Now, you may think that looks fine and dandy, but the math gods don't think that looks fine and dandy. Because we can't have radicals in the denominator. So what do we do to get radicals out of the denominator? Well, we multiply by the conjugate of the denominator. So negative 3 times 3 is negative 9. Outers is 3 square root of 3. Inners is 3 square root of 3. Last times last is negative 3. In your denominator, 3 times 3 is 9. Outers and inners are going to cancel. Square root of 3 times square root of 3 is 3. So your numerator is negative 12 plus 6 square root of 3. Your denominator is 6. So your answer is negative 2 plus the square root of 3. A little bit of work for tangent 1. A little more work than a sine or a cosine 1. We should do another tangent 1. The tangent of negative pi over 12. The tangent of negative pi over 12. That's like the tangent of 2 pi over 12 minus 3 pi over 12, right? So we go negative pi over 12, which is the tangent of pi over 6 minus pi over 4. Now, this is what I'm going to say, which could help you out a little bit. So instead of singing, maybe you should pay attention. I don't like pi over 6 with tangents because it involves fractions. What's a tangent of pi over 3? Well, the tangent of pi over 3 is square root of 3 over 2 over 1/2, right? Which, if you multiply both the top and bottom by 2, is just the square root of 3. No fractions there. So if I can use a pi over 3, or tangent of 60 degrees, in other words, if I can use the 60-degree angle or the 120-degree angle, that's a whole lot better than using a 30-degree angle or a 150-degree angle. Just saying. So we don't have the fractions involved. Okay? Now, we can work through the fractions, but what's another way of doing this? And we use the tangent of pi over 3 instead of pi over 6. Well, pi over 3 is how many pi over 12? 4 pi over 12. Now, 4 pi over 12, I can't use a 5 pi over 12, so that won't work. What's the tangent of 2 pi over 3? What's 2 pi over 3 the same as? What over 12? 8 pi over 12? Do we have a 9 pi over 12? So 8 pi over 12 is the tangent of 2 pi over 3. 9 pi over 12 is 3 pi over 4. Okay? What this does then is takes the fractions out of it. So it's the tangent of 2 pi over 3 minus the tangent of 3 pi over 4 all over 1 plus the tangent of 2 pi over 3 times the tangent of 3 pi over 4. Okay? So the tangent of 2 pi over 3 is negative square root of 3, because if pi over 3 is positive square root of 3, 2 pi over 3 would be negative square root of 3. The tangent of 3 pi over 4 is negative 1, so it's minus a negative 1, which is plus a positive 1, over 1 plus negative square root of 3 times negative 1, which is square root of 3 plus 1 over 1 plus square root of 3. Okay? No fractions on this one. Now, I still have a radical in the denominator. How do I get rid of the radical off the denominator? Multiply by the conjugate. Whoops. 1 minus the square root of 3. So if I multiply by 1 minus the square root of 3, my numerator is square root of 3. First times first is square root of 3. Outers is minus 3. Inners is plus 1. Last times last is negative. Oh, did I screw up somewhere? This is a negative out front. Ooh, yeah. Mr. Bierschbach had screwed up. Bad boy. All right, here we go. So, negative square root of 3. Outers is plus 3. Inners is plus 1. Last times last is negative square root of 3. In my denominator, 1 times 1 is 1. Outers and inners and conjugates always cancel. Minus 3. So I get 4 minus 2 square root of 3 over negative 2, which is negative 2 plus the square root of 3. Okay. Nine through 15 odds and 16. That's 5 problems. Get to work on those. What? No.